Hello and welcome to today's video where we are going to look into what limiting reactants are and how they affect our calculations when we try to calculate the mass of a product. Let's take some calcium carbonate and put it in hydrochloric acid. We get calcium chloride, water and carbon dioxide. We can see this reaction taking place as calcium carbonate will slowly disappear and will produce a fizz. As it reacts, the fizzing will be gone completely, and at that moment we'll know that one of our reactants has all been used up. Secondly, calcium carbonate has disappeared, which means that it is a limiting reactant because it has limited how much product can be produced. On the other hand, there is still loads of HCl left. So we can say HCl is in excess. The reason it is important is because the amount of product we get depends entirely on limiting reactant. If we add more calcium carbonate, more product will be produced. But if we add more HCl, nothing will happen. Now let's calculate the mass of sodium oxide produced when 115 grams of sodium is burned in air. First step first, write down the equation and balance it out. As we want the mass of sodium oxide, first of all, we are going to have to find the number of moles of sodium oxide that are going to be produced. And to do that, we have to work out the number of moles of sodium we started with. We use the equation moles is equals to mass divided by molecular mass. By putting in the values, we get 115 divided by 23 is equals to 5 moles. Now, by looking at our balanced equation, we can find out the ratio between sodium and sodium oxide, which is 4:2 and simply 2:1. For 5 moles of sodium, we produced 2.5 moles of sodium oxide. So now we need to find the mass of 2.5 moles of sodium oxide, and to do that, we are going to take our equation and rearrange it to mass is equals to mole multiplied by molecular mass. By putting in the values, we get 2.5 multiplied by 62 and we get 155 grams of sodium oxide. That's it. Thank you very much.